morning, everybody. Thank you for coming. I know it's the first lecture of the day, so I hope I'll be able not to let you go back to sleep. My name is Ofer Maor. I'm the CPO of Quotium. So what we're going to do today is talk a little bit about the relationship between application security and data security, and try to understand what is the purpose and what are the things we want to focus on when we're looking at those things. We'll talk a little bit about the current application security approach and where we believe they come short. The relationship between a vulnerability and a risk, and the relationship between an attack technique or a cool exploit versus the actual goal or impact that we have in our system. And we'll try to understand a little bit about the challenges that we see with existing security solutions and where they come short, and talk a little bit about a new approach on how to look at application security in a way that will be more efficient for us. So, a little bit about myself. I'm many years in the information security and application security industry. I've done a lot of hands-on penetration testing. I've worked with a lot of products, pretty much every product out there in the market. I've been involved in a lot of research. And actually, I ran a company of penetration testing, application penetration testing for many years. So we've seen pretty much everything around it. And we're bringing a lot of experience to the table and trying to understand those things and those problems. So I think the main issue that we need to look at is application security a mean or a goal. And I think a lot of people, and that's natural for every space or field you expertise in, when you do that all day long, it becomes your goal, even though it could be just a mean. And at the end of the day, when we look at application security, it's a mean, it's not a goal. Why? Where's the goal? So when I'm a hacker, when I'm doing an attack, cyber warfare, any type of this, my goal is always the end goal. Eventually, it's data, right? That's what we have. Money is data. It's recorded in the database. Healthcare information, IP, anything you want to steal, modify, get a hold of, or do something bad to, eventually stored somewhere as persistent data. And the application, at the end of the day, is more about a set of means of processing this data, working on that. So when I'm doing application security, I don't really want to secure the application, right? Okay, I do want to secure the application, but I want to secure the application so that it will protect the data that it's working on, not for the sake of securing the application. And so a lot of people say, well, right, so let's just do DB security, right? Let's just get a database firewall. But the problem is the database firewalls or any type of database security solution really struggles when the application is doing things, because the application is permitted to access this data, right? Obviously, if the application now wants to extract the record, it's probably fine. But then the other problem is that if the application now is insecure, I can make it extract the wrong record for me. So obviously there's a relation, and obviously we want to do application security, but we want to do it focusing on protecting our data. Another thing we want to look at is how well can we integrate application security into our development. I think most of the people who are working with application security agree that it's not something that we can do as a byproduct at the end of the day. We really want to get it as part of the R&D cycle. And it's again the same problem. If you go to developers, they don't really like security, right? How many people here went with a pentest report or something like that to a developer team and they said, yay, it's great you're helping us? Show of hands? Oh, nobody? Not a surprise. So the problem is, and when we start treating application security as a goal, they just get frustrated. They don't see the purpose. We flood them with too many work, and they end up not doing anything. So the problem is, and I'm saying, that the current approach is too technical. Now, with another show of hands, how many guys here got a penetration testing report or a testing report that was too technical and didn't really reflect any real-life threats? Just three? Are you still tired? Should I get coffee? So the problem is, obviously all the tools, but most of the consultants in this field too, they're people coming from the technology side. They look at things, oh look, it's a really cool way of injecting a new type of code into the third part of the application. And they don't really care if there's something that can be done with it that impacts your organization, that impacts your data. So there's too much work around that, too much focus on technology, too much focus on the code itself rather than looking at the system. So when we were a pen testing company, the first thing I would ask my people was, when they're saying, I saw this, okay, what does the application do? Where are the risks? If you were a hacker trying to gain some profit here, where would be your attack vector? And not just, oh look, there's a really cool process scripting and build this fantastic exploit nobody in the world built until now. And, well, why did you? I don't know, it was cool, so I spent 20 billable hours of that. And the problem is that we really have too many vulnerabilities for that same reason. Our consultants, our experts are really, really smart people, really technological people, and they like the cool attacks. And I'm not saying it's dead. We need those people, we need the research. Obviously some of these cool attacks tend to get important and to have a real impact. But they don't really know how to sift through the problem. So I think the main thing we need to do is to go back to the roots. Anybody who started with information security should know this: confidentiality, integrity, and availability. So those are the three pillars of security. And they didn't go away. We're just sometimes a little bit forgetting this. So the idea is that we need to look at our application with a risk-based approach and say, where are the problems and how each of these million vulnerabilities that we get, how do they impact my application? And if the people doing application security for you are not doing this, you should ask them to do it. For everything, every problem, every risk, where's the impact? What is it going to do? Which kind of data is it going to compromise? And how? And then it makes it much easier for us to start focusing on application, on the risk. So by taking data-oriented approach to application security testing, we can start finding what really matters to us. So the first thing we want to look at is logical versus technical vulnerability. So if we go back to this slide, right, with all the names, a lot of these, actually most of these, are what we call technical vulnerabilities. What does it mean? It's vulnerabilities at the code level. Injection, right, there's OS commanding and font inclusion and directory traversal and process scripting. Those are all very technical vulnerabilities, right? They all go around all kinds of programming languages, all kinds of devious ways to make the application behave a little different. But in reality, the more interesting vulnerabilities fall under a much more generic thing. Unauthenticated access, right? What does that mean, unauthenticated access? That's everything, right? If somebody can do unauthenticated access to my system, that's really bad. There are a million different techniques which people in our industry like to call logical attacks, which are actually ways to circumvent your authentication verification. And they're all around, fall under this category. And when you look at penetration testing, a lot of the companies doing that, a lot of people working around that are just touching those things while they're focusing 80-90% of their energy on the technical stuff. Because it's more routine, it's standard, it has a lot of cool exploits that developers that move to the dark side, meaning security, like. So looking at logical vulnerabilities, and then as I said, looking at the business impact. The business impact is really, really important in the sense that for every vulnerability, you have to look at the exploit that you can do with it. You found something which looks like SQL injection. Great. Now what can you do with it? I used to get people coming to me, look, there's SQL injection here. So it's like, okay, and what can you do with it? I don't know. So let's think together. Well, we can do a union select injection and steal all the database. Right. And can you tell me a little bit about the site? Yeah, it's an online marketing site. And what's in the database? Well, the data for the site. Oh, so it's all public. Well, yeah. So who cares, right? Okay, sure, I can do a shutdown of the system, so there's obviously an availability issue here, but it's definitely not a hugely critical catastrophe type of SQL injection as you would get if it was, your online banking statement and you could inject into the database that holds your money. So looking at the business impact, if you take, cross-site scripting, probably one of the most discussed issues in the world. How many people here were reported to have cross-site scripting in the system that they are responsible for? Yeah, don't be ashamed. Everybody gets cross-site scripting. It's okay. Most of the cross-site scripting, though, is what we call reflected cross-site scripting. There are different types of cross-site scripting. Reflected is the easiest one to find, is the easiest one to exploit, and in all reality, nobody really uses it for real attacks. Why? Because it requires me to actually make you attack yourself. I need to send you a link that you will click and will attack yourself. I'm not saying it's not a vulnerability, but in all reality, if I can convince you to send a link I send you by email, and you go for it, we could just do a simple phishing. I don't need to bother with all the cross-site scripting. And in reality, if you look at real attacks, there's very little reflected cross-site scripting going in the world. But if you go to OWASP top 10, number 2, cross-site scripting, of course, because it includes all the types, the ones that are dangerous, and then most of the people just don't differentiate. Okay, cross-site scripting, that's a critical finding, don't fix it immediately. So the level of exploitability, what can I do with it? So back in our penetration testing day, the motto was very clear. No exploit, no vulnerability. If you can't exploit it, then a hacker can't exploit it, then it's not a problem. So again, if we look at the risk approach, the problem is here. Unauthorized data modification, okay? And there are a lot of ways you can do it. They should look familiar from that slide with all the vulnerability names. I can do a parameter tampering attack, what we call logical attack, where I change the value of a parameter in an index, and I see the record of another user, and then I can edit it. That's one way to do unauthorized data modification. I can do a SQL injection and overwrite records, right? I can do cross-site scripting, take a hold of somebody else's account, and then through that do data modification. But as a security officer, I care about the title. I care about unauthorized data modification. That's a risk. Is it a risk? That's easy for you to decide once you get the information. Say, okay, I don't care that somebody changes the data, or let's stop everything and shut down the app because this is the biggest risk for our company. I don't care about the way it's done. That's just for developers. So when we look at the existing solution, they don't do that. If you look at the market now, there are very few companies, penetration testing companies, that actually look at risk and impact, and the tools are completely not there. If you look at application scanners, all they do, they touch the front end of the application, they send request response, they test purely for technical vulnerabilities. They don't see the data. Obviously, they're not on the database. And so they can't do any of those important things around data. So you end up buying a solution, running it, fixing all your reflected cross-site scripting, and some of your SQL injection, which is good. SQL injection is definitely important, but you still miss out on all the authenticated access and all the unauthorized access and all those things. And the same with fast. Okay, it's just another type of technology which still fixed on code, looking at code security rather than looking at data. So the result is that the ROI is terrible. You spend a lot of energy, you spend a lot of money on those tools, or the companies, or the pen testers, or your in-house testers, or whatever way you chose to go. You spend a lot of money on fixing problems that may not be really that important, right? And you spend a lot of hours sorting through these problems, trying to figure out what you're doing, and you end up paying a lot of money for application security. We see that. We see that the budgets of application security are growing. The overall expenditure grows 30-40% per year to year, last 3 years in application security. But the results are not going up at the same pace. So we still see that, and I see, the company I had which we sold, they're still doing a lot of pen tests. It's still, everything's still hackable, all the problems are still there. We don't really get to a great solution. So we spend a lot and we get inefficient results. So that solution, of course, is to bring the data into application security. So not to look just at the code, but to look at the system, to look at how the application is working, how the code is working. Obviously the code is a big part of it, but to look at the data. Meaning that when we are looking at how the application is running, we can say, look, this part is handling this data, and this module is dealing with this data. And when running with 3 different users, they each get a different part of the records in the database. So we should be able to classify data as part of this testing, right? So a lot of the things that you see DB protection tools do, but they only do it from the database side without looking at the application. So you really want to get that together. So automatically classifying the data for sensitivity. So how do we do that? How can you say this is sensitive and this is not? So we can get a lot of heuristics around the structure of the data, right? Credit cards always look the same. Social security numbers always look the same. Passwords tend to come from specific fields in your browser. So when you look at the entire application and you look at how it works, it's quite easy to classify the data. Classify ownership data. I have 5 different users in the system. Each record belongs to which user. Why do we need to know that? So when I test your application, I can tell you now, user A is able to access data that belongs to user B. That's wrong, right? And so we want to be able to identify vulnerabilities which pose a real risk, and then we can focus our energy on finding only what's important, not fixing all those bad coding problems, all those vulnerabilities that have absolutely no risk into our application. And then we can work with that, and we can test real use cases, we can test real business transactions, we can really look at what the application is doing and how to fix it. So when using an approach like this, it's also much easier to get it into the R&D because the overhead is much lower, right? We're not telling the R&D now, look, there's a report with 4,000 issues in their code that needs to be fixed, right? We're telling, look, there are 20 problems. If you want, we can show you each of them that it's really dangerous. At the end of the day, I agree, developers don't like security, but they do care at some level that the application won't get hacked, right? They're still part of our organization. They still want their apps to be good. And if you tell them, look, in this specific instance, it's really easy to steal all your database, they'll be a lot more cooperative to tell you, okay, so. So with this approach, you can become a lot more efficient and with much better ROI because you fix only what matters and you do it early on and you don't mess with anything that's irrelevant. So, a few words about the company I'm with, Quotium. We do, when we talk about, I'm not going to talk about the product here, but if you want, you can come to our booth. But, it's the philosophy we've taken from penetration testing and really think it's the right way to go. Questions?
Yeah. Song? You got a song? Yeah, song.
I cannot hear you.
I can't hear you either, in fact.
Right?
pass it back and then once it works. We have a broken microphone. I'm sorry, we have a broken microphone.
You just want to speak up and out loud.
You're talking about automatic data classification. Do you mean automatic in should do it as a matter of course, or automating as part of some, magic data classification? Does that make sense?
Yeah, so the question was, what did I mean by automatic? So the point is that whenever if we're talking about automated tools, which is what we'll get in the R&D, we want those tools to be able to automatically, through magic, as you said, or technology, to classify the data as part of the testing. So when they look at the application, they look at the code and the data, and are able to say, this data is sensitive, this data belongs to this user, this data should be protected, and then test whether the code is doing that, in fact. Okay? Other questions? Morning, huh? Okay? Thank you very much.